It's recording.
That's exciting. Right, let's go. Take 158. Well, really take two. But this is John Anthony with Ariana Anthony. We're looking at the latest tech that we've built recently. For those of you that saw my blog 2-3 weeks ago, you saw that I was putting AI into a browser. It's advanced quite a lot since then. Still playing around with the same concept. So I'll just show you something simple. So we'll put your name, Ariana Anthony, into Google, tell it to hit search.
See what comes out.
See what comes out. Exactly. Now, not as simple as you might sound, not as simple as you might imagine, because we are not putting in specific commands, we're just putting in natural language as we type it. We're expecting it to understand the natural language. So what have we done? So I've actually told it to make a task list for itself. So in the large language model, first of all, we tell it that it's a browser expert. It knows everything about navigating around a browser. So we've told it to search, but the first thing we tell it to do is we tell it to be organized. So we say, hey, go make your own task list. Now, it'll take a screenshot because sometimes it's often better to navigate around with a screenshot than it is to read the HTML. Might be a language model, but we've also got a vision model in there as well. And there's the screenshot that it took. But for what it's doing right now, it actually doesn't really need the screenshots. It's pretty good. So here you can see it's already made a task list for itself, which is great. And now it's worked out, it's done its first task list, it's navigated to Google. The next thing it needs to do is work out what the search input is. It's done that. Then it fills in your name in the search box. Now it clicks search. And then it clicks on the first search result. So what you can see is it's broken down the instructions into simple tasks for itself. Then it goes through the tasks for itself. But actually, behind the scenes, what it's doing is it's maintaining its task list. It's giving instructions to a tool call. So the most important thing that I really want to convey with this, if you learn one thing from this video, it's the importance of tool calling.
What is tool calling?
So tool calling is where the large language model returns a tool that it wants to call. In this case, it's calling a tool that makes a task list. And it's saying, hey, this is what I want in my task list. Now the tool call expects a JSON format, so it's returning a JSON format for us.
And what other kind of tools could you put in there?
So for this, I've written about 15 tools. So everything from work out what the boxes are on the page, work out where the header, the footer is. I've written tools to take screenshots. I've written tools to fill in text. I've written tools to click buttons. Everything that it might do is a tool, and it's got a list of tools that it's allowed to use.
But could you write like an infinite amount of tools for it?
Yeah, you could even tell it to write its own tools, and a lot of people take that approach. But if you get it to write its own tools, that's pretty dangerous. In my opinion, you're probably asking for trouble. So I'd rather write the tools and tell it what tools that it can use. Now I can sanitize the input that goes into that tool, and then there's a lot less risk of it doing something unpredictable. You can make it very powerful. I prefer to make it less powerful because even less powerful, it's incredibly useful.
Makes sense.
And so here you can see the tool being calling. So LLM reasoning, that's the language model. Below that is the task. It's the tool that it actually uses. So you can see in the steps below, it goes language model tool call, language model tool call, language model tool call, language model tool call. It's alternating. Every time it calls a tool, we go back to the language model to make sure that the tool result was good. And then it moves on to the next thing that it wants to do. So sometimes that's updating its task list because we told it to be super organized. Sometimes it's actually doing something as part of that task list. And it might need to call 3 tools before it's done. So, it's smart enough. It depends how well it's broken down its task list, but typically, it will call at least 1 tool, and it will always update its task list as well. So here you can see, again, it's housekeeping, it's updating a tool. And then it'll say, hey, I've done that successfully, and then move back to the language model. If we look further down, we're at the point now where it needs to work out where the search box is. It can't enter into the search box until it knows where the search box is. So it finds elements by purpose, and the purpose of this is a search input. And the tool call, will then...
your own purposes?
Oh yeah, absolutely. There's a list, and the tool knows what it's allowed to use, but actually it's going to come back with a list of elements. So elements are elements on the web page.
Oh, okay.
And there are actually several search inputs here. There's a search input for image recognition. There's a search input for voice and there's a search input for text. And we wanted to use a search input for text, so we give those back to the language model. The language model will then update its task list to say, hey, I've worked out what the input boxes are. It will then move to another tool which fills the input. And here you can see it knows which one to use because we told it which search boxes there are, and it puts in Oriana Anthony into that search text. Mm-hmm. After it's done that, it will work out where to click, and then it'll click on the search box. So again, it goes back to working out the elements on the page, works out what the click box is, and then clicks the search box and moves on to its next step until it finally gets to the end and it clicks on the first search result and it says, hey, I clicked on Instagram. It now knows it's completed all of the tasks, so it says all tasks have been completed successfully.
Quick question.
Yeah.
Who did this snazzy UI? Because it's looking much better than it did a week ago.
Not me, that was Safi. That's the one bit that I can't even do vaguely. Yeah, I'm very jealous of his UI skills.
Big ups to Safi.
Yeah, thank you, Safi. So if we look at this and take it a step further, tool calling is about how AI breaks out of just being a chat box and interacts with the natural world. If you look at the big companies, if you look at Perplexity, if you look at OpenAI, if you look at all of the big players, they all have tool calling. They have agents that they're releasing right now that allow you to do things like interact with browsers, interact with desktops. But my argument here is you need to be writing your own. So these are all of the tools. I've written each of these tools by hand. You can see we've got tools here to explore the page, to find elements by purpose. We've got tools to get the landmarks. So, where is the form on the page? Where are the menus? Where is the header? Where is the footer? So I have tools to gather information and I give those to the AI. And then I have tools to take actions. And the actions aren't that complicated. I've got tools to click an element. I've got tools to take a screenshot. I've got tools to press a key, to press a button, to click a button, to hover, to scroll. I've even got a tool here to execute JavaScript. You'll notice that, but I don't use it. It's not enabled. There's a special override to enable it. At first I thought, hey, let's let the AI write its own JavaScript. I thought about that for about half an hour and then decided no.
What changed?
It's a risk. There's always a risk. If I write the tool, I can control exactly what it does. Click on a box, you're only allowed to input these parameters. There are a lot of scare stories about AI, but the reality is that you could have AI that has a prime directive that's in there that you don't know about. When it gets an opportunity, it might do something evil, something dangerous, or it might make a mistake. AI's been deleting databases recently. I don't want to give it that much power. It's got tools. It can only do what the tools allow it to do. The tools are restricted. All the input to the tools are sanitized. If the AI tries to do something that it's not supposed to, it simply won't work because the tool won't be expecting the correct input. So JavaScript would allow the tool to do practically anything. It's a bit of a cheaty, lazy way out of doing what I want it to do. I prefer to write each tool individually, and then we don't have the risk. Now, these are virtual tools. These are tools to control a browser. This fundamentally is an example of what you could do with tool calling. But we could have tools that work on a car production line. We could have a vision tool that looks at the production line. It might look at the supply chain lines coming in off the side. It might go, oh, we're about to run out of bumper parts on that supply chain. Let's slow things down. And then it sends off a message to say, hey, we need more bumper parts. And some other part of the factory fills those up. So we keep the entire production line running constantly. We would just write different tools there, but it's the same principle.
Could you, for example, make a tool that maybe looked at the most recent fashion trends and then made a mood board of all of the trends?
Yeah, absolutely. We can do... So some of that will be the basic browser tools that we've got. There's another thing called MCP. And these are ways of interfacing with some of these tools. So you can use MCPs to...
What's MCP?
Okay, so MCPs are Model Context Protocols. This is something that Anthropic created as a way of talking from AI to another platform like Figma or like a SQL database. So what you're seeing here is tool calls. There's a bigger umbrella term of MCPs which allow initially just Anthropic's which initially allowed Anthropic's AI, but they made it as an open standard and now everybody uses it to talk to third-party systems. What we're doing with tool calling is much lower level. So we're not integrating with Figma, we're not integrating with a SQL database, we're actually writing tools to do very specific things. For what you're using, we would potentially integrate MCPs because we're talking to systems that already have a language that we can talk to them with. So we don't need to write our own tools for those. But when it's our own system, when it's our own production line, when these are specific tasks that we want to accomplish, such as looking at the state of a rocket booster, and maybe making adjustments there, we won't be using MCP necessarily. We might. We will. I would say you write your own very specific tools. And it's interesting, when you're looking at a lot of these cloud sets that are available, they're designed to run in the cloud. The model that you're looking here runs locally on my Mac. It's a 7B model. That means it's 7 billion parameters. I think it runs in about 5 gigs of RAM. It's tiny and it's fast, and none of the AI data or that instruction set left my computer. I didn't need to go into the cloud. The first time I ran this and I demoed it, the AI thinking was happening in Claude Sonnet. That run would typically have cost about 50 cents. So not cheap either, but it was very effective. What I found when I initially tried to run that with a small language model is it didn't work. What I had to do was make the language model instructions far more accurate, far more concise, and I had to make the tool calls much, much better. So I actually spent most of the last 2 weeks of the work that I was doing on this, improving the tools and their quality, improving the instructions to the language model, improving that conversational history, and now I can use a tiny model that runs on my laptop. That now means I don't have to pay 50 cents just to do a Google search, which I don't want to do. I can leave it running on my laptop. It doesn't cost me anything apart from a tiny bit of electricity, and all my data remains private. So again, it's another argument. If you want to use somebody else's cloud and rely on that, that's absolutely fine. It's quite dazzling. It's very exciting. But,
if you're working with sensitive data.
If you're working with sensitive data, but more importantly, this is an AI race. If you're running a company, and I use the example of a production line, but it can be anything. It can be a digital production line or it can be a physical production line. The companies embracing AI right now, or the startups using AI, will be the winners. In my opinion, it's a very bad idea to sit on the sidelines and watch AI overtake you, unless you think you're going to be really good at being a fast follower. But if you can't win if you're not playing, and my strong suggestion is think about breaking out of just being a chatbot user. Think about breaking out of using one of the multi-billion-dollar tech companies' tool sets and think about writing your own. Because, if this proves anything, it proves that it's doable.
Or get John to write it for you.
You can get me to write it for you, that's the thought. But more importantly, what I want to prove is you can do this. It's very, very, if I can do it, you can do it.
Last thing, what about the data centers?
This is where it gets really interesting. There's a huge cloud industry. And what's interesting is at first cloud seems incredibly appealing, and there are a lot of reasons why it is. But you lose control of it by comparison with what you used to have. And now there are tools such as OpenStack, they've been around for a good decade now, where you can actually have completely your own cloud with automated deployments, managed, scalable. You don't necessarily need one of the big cloud providers. Again, you've got your own hardware. Because you've got your own hardware, or you've got hardware in a data center, and we are working with a data center builder at the moment who build data centers in places like Norway, run on hydroelectric power, which I think should be important to everybody, in the EU region, which is quite nice for ring fencing data, but they build huge data centers in America. They're actually an American partner with a European base as well, which is very nice. With B200 NVIDIA cards. So we can train our own models, we can run models incredibly efficiently, very, very fast models as well. So, it's one thing running one model at a time. You can run a huge model or you can run lots of small models. But really, once you get to doing this seriously, you probably want to use one of the big cards. You probably want to run it in a data center. And again, if you do it this way, you have complete control of your own data because there's risk there. I think a lot of people quite felt quite reassured when they had their own server rooms, and then we thought, hey, we've got to distribute that, we need 2 places. Oh well, let's use the cloud, it's redundant. But now you can have redundant data centers where you have complete control of the hardware, and particularly this partner that we're working with at the moment are fantastic for putting racks up and putting entire data centers up that we trust, and you can move towards that now. For me, one of the big advantages of that is that you avoid runaway costs. You have complete control of that. You can't. You don't run the risk of something expanding beyond what you're paying for in terms of the hardware, which is a big point. And then all of the privacy concerns, and then to be honest, just control over your own hardware. But when you use something like OpenStack, you still get the full advantages that you get with a cloud provider. You do get the auto scaling within the amount of hardware that you have. You get deployment pipelines, you get Terraform builds, which means that you've got not instant disaster recovery, but instantly launchable disaster recovery. The disaster recovery itself takes time to run, but it's there at a push of a button. And all of these things are incredibly important these days. It's why we love cloud, but having your own cloud with Terraform and with OpenStack, for me, is a great solution.
Cool, very interesting. Oh, it's such exciting stuff to see.
It is. Now you just need to think what do you do with your tool chain empowered AI once you start to break it out. This is where it gets serious, whether it's farming, whether it's car manufacture, whether you're making biscuits, and
finance or fashion.
Finance, fashion, risk management. We're doing a lot with risk management, obviously, for the World Health Organization, but that risk management transfers everywhere. Fashion, like you say, feedback, marketing. Once you have the tools to put information out, bring information back, it's an endless amount of freedom, really, to use AI. And when you control your own tools, that's when you can really get creative.
Cool.
Call that a wrap.
Bye bye.
Doobie doobie doo. Boop boop.
Doobie doobie doo, doobie doo.